morning, dear students. Today, for 12th HSC Science stream from Mathematics section 2, we are going to start with the first chapter, Differentiation. This chapter, Differentiation, already we have studied in class 11. So, in today's class, we are going to revise the basic points, some important rules, and most of the basic common functions and their derivatives. Also, we are going to see how to obtain derivative of a given function by first principle method. So first let us see three basic concepts where differentiation can be defined. So if y is f of x is a function which is differentiable with respect to x. Any function fx differentiable with respect to x, then f dash of x, which is the derivative of this function fx, can be obtained within open interval for x tends to 0. F of x plus x minus fx upon h, where h should not be equal to 0. If in this case h becomes equal to 0, the whole derivative will become non-defined. So h approaches towards 0. For example, h tends to 3 doesn't indicate h is equal to 3. H can take values 2.9999 and so on, or 3.000000001, but it will never take value equal to 3. Similarly, you can apply it for any natural number, but here we are specific about h tending towards 0. So tends means approaches towards the nearest value, but not equal to that value. So this is the first concept about differentiation with respect to x. Also, we can say for any given point x is equal to a, for any given point x equal to a in open interval, then in that case f dash of a, instead of x we will have f dash of a at point x equal to a, will be limit h tends to 0 f of a plus h minus f of a upon h. So these two you might have studied in class 11, where they were known by first principle method. So by these first principle methods in class 11 you might have obtained derivatives of various functions. The listing of those functions we'll see soon. And the third point which will help us in defining differentiation is if delta x is small increment in value of x, if delta y is small increment increment in value of y. These are two things. One is x, so its increment will be delta x. One is y, so other will have a small increment delta y. Then f dash of x, which is also defined as dy by dx, means differentiating y with respect to x, is also written as limiting value delta x tends to 0, delta y upon here delta x tends to 0, but delta x not equal to 0. So these are the three important points which will help us in understanding throughout what happens exactly in differentiation. These two belongs to first principle method, and this is in general definition of derivative. Students, you might have also come across this kind of definition in the chapter measurements for 11th Science Physics first chapter. There you might have come across something called as relative error or anything of absolute error in that case, where we have used delta y and delta x terms for first time over. The first article is for a function y equal to fx differentiable with respect to x, and the second one was defined at any point x equal to a for open interval. So I hope that the basic definition of differentiation is clear to all of you. Let us proceed further now to the various functions and their derivatives with respect to x. Once we list out those functions, then easily we can see the different rules as well as what is the meaning of composite function, that is function of a function. But before that, the basic thing, left hand side I will write function, right hand side I will write f dash of x, which is equal to dy by dx, which will be the derivative of it. Let us go with basic one. Always remember, if there is a constant term which is a function, if there is some constant which is called by c or some authors call it by k, then under such situation always remember the derivative of a constant is 0. Derivative of a constant is 0. For example, if somebody asks you to differentiate 3 with respect to x, so the answer of this will be 0. If somebody asks you to differentiate 1000 with respect to x, in that case also the answer will be 0. So always remember, derivative of constant terms or a function which is representing a constant is always 0. Second one is x raised to n, where n is any natural number. Under such situation, the derivative of x raised to n will be n x raised to n minus 1. N x raised to n minus 1. N into x raised to n minus 1. Like suppose we have, for example, x raised to 3. So in this situation, our n value is 3. So the value over here will be 3 x x raised to 3 minus 1, that is 2. So derivative of x cube will be 3x square. Always keep such things in your mind. Then derivative of e raised to x. In this case, it is remaining the same. Derivative of e raised to x remains e raised to x. If we have instead of e some constant value a raised to x, so derivative of a raised to x is going to be a raised to x log of a. So these four students, you will come across these functions frequently. You will come across constants, you will come across x raised to n. Most of the quadratic expressions are there, or higher power expressions will be there, in which it will be useful, x raised to n. Then you will have exponential e raised to x, and then you might come across a raised to x also, which is a raised to x log a. Then comes root of x. Root of x will have the value 1 upon 2 root of x. This one I can explain you directly. There is no need of going towards first principle method. So if it is root x, so how to get 1 upon 2 root x? It's simple. Root x can be written as x raised to half. Root x can be written as x raised to half, where n value n is half. So in that case, x raised to half will be half x raised to half minus 1. Half x raised to half minus 1. Then this can be written as half x raised to minus half. Now this x raised to minus half, when goes in denominator, will become 1 upon x raised to half, which is 1 upon 2 root x. So that is why derivative of x raised to half or root x is 1 upon 2 root x. So that point is clear in this way. Now let us proceed further for some other functions. F of x and its derivative f dash of x is dy by dx, and see what happens. I have 1 by x as a function. If 1 by x is a function, then its derivative comes out to be minus 1 upon x square. Now for 1 upon x, the derivative is minus 1 upon x square. Let us see how do we get this minus and introduce. All these functions, their derivatives can be obtained, like say 1 upon x. So it's the inverse. You can also write it as x raised to minus 1. In that situation, d by dx of x raised to minus 1. Your n is minus 1 in this case. So minus 1, x raised to minus 1 and minus 1. So it will be x raised to minus 1. And x raised to minus 2 can be written as minus 1 upon x square. So this is the way we get derivative of x raised to minus 1. That is 1 by x. Then after this we have a continuous list of trigonometric functions. Let us see sin x. Derivative of this by first principle method, you will get cos x. After that you have cos x, so its derivative will be minus of sin x. Then you have tan x, derivative of it will be sec square x. Derivative of sec x will be sec of x into tan x. Then you have cot of x, which will be minus cosec square x. And we have cosec x, which is minus cosec x into cot x. So these are the list of trigonometric functions and their derivatives. Basically they are very important because further while solving numericals from the exercise you will mostly come across the trigonometric functions. Once again quickly we revise. Sin x will have derivative cos x, cos x will have derivative minus sin x. Now one may think from where all these answers they arise. You might have done this in class 11. All the answers, not only for trigonometry but for any function, can be obtained by first principle method. Tan x, sec square x, sec of x, sec x, tan x. Cot of x is minus cosec square x and cosec x will be minus cosec x cot x. And besides this, two more additional are there, which I will highlight here. Log of x, but here it is to the base e. Under such situation, log of x derivative is 1 upon x. And if you have log of x to the base a, under such situation it is 1 upon x log of a. So this is the answer. Now students, they generally think like here it is 1 upon x log of a. Why don't I write here log of e? The answer is very easy. Log of e to the base e, answer is 1. So that's why we don't write here log of e. But here it is log of some constant value a. So log of a. So value of log of x to the base a will be 1 upon x log of a. So these are all those important 14 formulas which are very important for studying derivatives. Now let us study 4 important rules which are useful in solving the exercise of differentiation. Sum, difference, product and quotient rule. The product and quotient rule are also known by UV rule and U upon V rule. The next article for us is rules of differentiation. U and V are differentiable with respect to x. There are two functions u and v which are differentiable with respect to x. Then if somebody wants to find differentiation of their sum, differentiation of sum of two functions will be the sum of their individual differentiation. Differentiation of sum of two functions will be equal to sum of the differentiation of those individual functions. Second will be difference. Differentiation of difference of two functions will be difference of their differentiation. Now the most interesting one, product u into v rule. This rule is generally called u into v. There are two functions u and v. In this case, which are differentiable with respect to x. So in that case, it will be u into derivative of v with respect to x plus v into derivative of u with respect to x. And then comes the quotient rule, or they call it as u upon v rule. This is given by v du by dx minus u dv by dx upon v square, where v square should not be equal to 0. If v square is equal to 0, then the whole differentiation will become not defined or infinite. So these are four important rules which one should know if you want to proceed further in the topic of differentiation. Now after that, till here you might have done in class 11 and examples based on it. What we are going to do today, we will just have a look on what is composite function. Composite functions are also called functions of function. Exactly before going to the theorem, see what happens. Generally, theorems are taught in classes. Like if a class is going on of differentiation, and in that if I highlight more on the theorem, you won't understand what is composite function. But if I start with an example to tell you what is composite function, more chances are there you will understand what is there in that topic and why to study it. Then again we will have to construct a new set of these functions and their derivatives. So composite functions, that is function of function. We are going to see function of function. What do you mean by function of function? See, I told you d by dx, if you can refer to our list of formula, d by dx of sin x was coming out to be cos x. Right? But dear students, if
instead of x, I will have anything over there: logarithmic, inverse, algebraic, exponential, trigonometric, anything. So here I am having an exponential function. What do you mean by composite function? Please try to understand. Like derivative of sin x is cos x. So focus on with respect to x. Here you have variable as x. Instead of x, we are having e raised to x. E raised to x is a function, and sine is also function. That's why composite functions differentiation is called function of a function. What to do? Like sine has derivative cos, here also I will write cos. Instead of x, I have e raised to x, so I will write that also. And after that, the additional part which is interesting is whichever additional function is there, you have to take derivative of it again with respect to x. This is the final answer. So now it will be cos of e raised to x, and derivative of e raised to x is e raised to x. Dear students, please do not try to multiply these two values, because this e raised to x is the angle of this cos. So we are not supposed to multiply this e raised to x with the multiplier e raised to x. This is the additional part of it. So derivative of function of a function. Let us see one more example. We can also take two trigonometric functions, d by dx tan of sin x. D by dx tan of sin x. So we are aware that derivative of tan x is sec square x. So instead of x, whatever is the function here, you have to write that in composite. So it will become derivative of tan of sin x will be sec square of sin x, and into derivative of the function d by dx of sin x. So it will become x square sin x, derivative of sin x is cos x. So this is called composite function. So I hope whatever I taught you today was definition related to differentiation. 3 points I told you in that. Then we collected a whole list of 14 different functions. What are their derivatives? Then we saw 4 basic rules of class 11 for derivatives. And then we have just started with what do you mean by composite functions, that is functions of functions. In the next class, we will try to revise more problems and then we will see the exercise. Thank you very much.